Thanks for joining. We have a lot of room in the front if you want to move up front. That way we can interact better. So thanks, everyone, for joining today. Today we are going to talk about scaling your SAP HANA workloads on the new EC2 high memory instances with up to 12 terabyte of memory. My name is Pranav Parekh. I'm a product manager in the EC2 business at AWS. With me today is Stephen Jones. Steve?
Hey, folks. Thanks for coming out tonight. I know that we are all the stands between you and probably beer, so we'll do our best to finish on time. I'm a director at Amazon. I've been there for about 7 years, working specifically on kind of our SAP technology and working closely with folks like Pranav to bring instances like this to life so you can run your mission-critical workloads on AWS. We're also joined today by a customer, Matthew Hubbard from Whirlpool. You'll get to hear a little bit from him in just a moment. But for now, you want to get started?
Sure, yeah. So what we want to do today is talk about the EC2 high memory instances, which is the newest generation of large memory instances that we launched earlier this year in September. Before we do that, though, we want to take a little bit of time and talk about our history of supporting SAP workloads on AWS and show you some, share the rationale behind these instances and why we actually got to thinking about these instances and how we build them. So before we dive right into the instance architecture and the instance product details, I want to invite Steve and talk a little bit about the SAP business at AWS.
Let's back up maybe a little bit and pull the audience here. How many of you actually run SAP solutions on AWS today? All right, awesome. Now, how many of you are actually running SAP HANA on AWS today? All right, awesome. So much of actually what you'll see today has been driven by customer feedback, right? We like to do a lot of what we do based on customer needs and input, which is why we made some specific design decisions and architecture decisions specifically for these big platforms as well. But before we get into that, let me talk a little bit about kind of where we've come. So we've been at this for about a decade now, right? So we started with SAP themselves as a customer way back in 2008. Did a lot of interesting things together as we kind of started looking at what were some of the options and some of the needs that we needed to make on our platform to be able to support SAP workloads. And as we started through early certification work with SAP, I have to be honest with you, we were actually working out what this really meant together, right? So a lot of learnings together with SAP along the way. You'll see some of the early certification work was around not really business critical applications like business objects, which is more for data and analytics and visualization. Rapid deployment solutions, that's not an AWS RDS solution, but SAP has solutions called RDS. But as we got into some of the more classic workloads around ERP based on NetWeaver, a lot of design aspects really went back into underpinning our platform, which took quite some time. But we learned a lot along the way. Somewhere in that curve, around 2011 or so, SAP came out with some new technology called HANA. In the early days, it supported in-memory workloads, primarily around data and analytics. And so we had, I think, an emerging platform, but customers who had already started deploying on our platform were starting to ask what the deployment options were. And at that point, and I'll get into this a little bit more later, there weren't a lot of hyperscale options for deploying HANA.
They were mostly deployed on 4-socket or 8-socket architectures at that point.
Yeah, at that point, it was actually only supported on an Intel E7 processor family. So back in that time, the only Intel processors that we actually built platforms with were the Intel E5 commodity-based platforms or chips.
That's right.
And so a lot of the early certification work, once that was kind of done and out of the way, we started really pivoting towards building purpose-built equipment. Specifically for HANA. You'll see a little bit more about how that evolved over time here in just a moment. And then we started really working closely with SAP on programs, migration offerings, and some of their own offerings like HANA Enterprise Cloud, which today is underpinned as well by AWS platform. Some customers can also run a fully managed version of SAP HANA and those types of landscapes, and leverage SAP to actually do all the managed services and the goodness that comes with that as well. And many of the other properties that you see here also run on AWS today. And so really, running SAP on a hyperscale platform, on AWS in particular, has become the new normal for business-critical large enterprises. And today we have thousands of customers running SAP business-critical solutions on the AWS platform. And many of these customers you'll recognize. These are the ones that are public, that have been willing to speak about their experience. But again, it covers a lot of segments and industries, companies of all sizes, from big oil and gas companies like BP, to big retailers like Uniqlo in Tokyo, to big large bottling companies like Coca-Cola, all making this journey and learning from each other and really providing a lot of feedback that goes right back into our platform, which is why you see what you're going to see today. For now?
Sure. So I would assume that almost everyone here knows what EC2 is and what instances are. But for anybody who is new to the AWS journey and who is very familiar with the SAP side of the business and technologies, but not the AWS side of things, I want to give a quick 30-second intro to what EC2 instances are. Simply put, EC2 instances is compute in the cloud. These are servers that offer you virtualized or bare metal instances with different purchase options where you can purchase on demand or you can purchase on longer term commitment with a whole suite of networking and management services. This is your compute environment in the cloud. And what we want to do today is talk a little bit about how we actually went about building different cloud solutions, different EC2 instance compute solutions, specifically for running SAP workloads, and within that, specifically for HANA. Before we get there, I do want to call out that whatever we do, we leverage the ability to offer that service throughout the world. When we started the EC2 instance availability more than 10 years ago, within the first 5 years, we only had 4 global regions. Next 5 years, we had 7 regions. From 2016 to 2018, we had 8 regions. And now, we have 5 new regions coming. So we are expanding our regional footprint at a constant pace to make sure that we're not just offering the right solution and services that you need in one region, but we are offering that in every region in the world that allows you to offer the best experience to your global teams where they sit today. Steve, do you want to talk about this?
Yeah, so there's a myriad of EC2 instance types out there, and for anybody who saw Peter DeSantis, the keynote last night, you know there's a lot more coming. This is the current generation of our compute instances across a number of dimensions. And so we have compute optimized instance families, right? So based on the CPU dimension, they provide the best bang for your buck. There's a memory optimized family, so that's the R family. And then there's a kind of a general purpose. And so what we see typically is in very large distributed production SAP deployments, including HANA, right, the application server tier leverages the C family. In non-HANA environments, right, especially when you're looking at running things like Oracle or DB2, still underpinning an SAP system, customers are typically using the R family. Although some of the smaller HANA deployments actually start bleeding into some of the larger HANA instances, like R5, 24XL, and the R5 Metal, which will be coming. The general purpose instance, they carry a nice balance of CPU and memory. These are typically used for non-productive environments where a customer may not necessarily know from time to time where they're actually going to need more CPU or RAM, or what the user profile is going to look like. It's super simple, simply a start and stop exercise to move in between instance sizes within a family. You can also move in between families, right? So if I'm running an R5 instance and I decide, you know what, I'd rather have an M5 instance for performance reasons, because maybe, again, I don't quite know what the mix is I need from a CPU and RAM perspective. Again, with an API call or a simple stop-start exercise within the console, I can actually move between families even.
We're actually going to demo that today.
Yeah, we could do
Probably.
that. Yeah, sure. What you see here, too, is there's a lot of work that goes into actually making sure that these are certified and supported by SAP for SAP workloads, right? So we We do a lot of benchmarking, which is why you see the SAP's ratings here. SAP's ratings are an SAP metric of sorts that actually denotes the number of sales and distribution documents you can actually push through a system at its peak, right? So we do a lot of benchmarking. We publish these benchmarks so that customers can actually see what kind of performance profile they can get with these different families. Now, the really interesting thing is, once a customer lands on the AWS platform, they can start taking advantage of additional generations. I mentioned these are the current generation of EC2 instances. There's a whole myriad of EC2 instances that have come before that are also certified, and they carry different performance profiles. So I'll give you just a quick example, right? So the C5 family carries about a 26% performance improvement over the previous generation C4 family. And it also comes at a lower price point. So customers who are running, say, on the C5 family, their application tier, can immediately get additional benefit and performance improvement by moving to this new platform without a lot of data movement and those types of things which traditionally happen in an on-premises
That's
data
right.
center, right? I'll just talk quickly about we introduced some time ago, a couple, 2 or 3 years now, the X1 family, which brings a larger amount of RAM. These were purposely built and designed for HANA. More on that.
They were the first ever EC2 instances to run on a 4-socket platform.
Yep, that's exactly right. So let's dive into that a little bit, right? So I'm going to wind the clock back just a bit, right? Go back to 2011. SAP has just introduced HANA. We are, again, largely a commodity-based platform. Actually all of our platforms were 2-socket at this point. And our largest virtual machine was 244 gig. And so we approached SAP because we had some customers who were already running on the platform. They wanted to run some smaller HANA workloads. And back then, the HANA workloads were data marts, which supported a scale-out design. And so we thought that there was a good use case there for customers to be able to make use of these platforms. And so working really closely with SAP to prove out the performance profile of even these smaller systems, we are actually able to offer, fully certified, the first certified 2-socket-based platforms. Very quickly, we found that customers were having some success with this, and they wanted larger and larger systems. And SAP started actually introducing additional functionality and features with the HANA platform, including underpinning very large workloads, scale-up workloads like Suite on HANA, and then later S/4HANA that required very, very large scale-up systems, which led us to actually design and implement the first ever 4-socket platform, not just on EC2, but any hyperscaler to offer a 4-socket platform with up to 2 terabytes of RAM. And we quickly, again, based on customer needs, pivoted and doubled the amount of RAM available with the X1E platform up to 4 terabytes, and that was about a year ago.
Yeah, and we were actually here last year at re:Invent talking about the launch of the 4 terabyte platform.
Yeah, so for now, why don't you just talk a little bit about what we just announced just a few months back?
Yeah. So 2 months ago, we launched 3 new instance sizes with 6, 9, and 12 terabyte of memory. Customers who were running on our 4 terabyte X1E instance over the last year or so, as they experienced data growth, they asked for options to run even larger memory databases on EC2. And that's when we decided to take a journey to build this completely new family of instances to offer up to 12 terabyte of memory. So let's dive right into that. What I want to talk about is how we actually got to designing these instances. We looked at the industry landscape, and what we found was that the most common way to run HANA was to host the large HANA systems in on-prem or colo deployments and then connect them to the cloud. Customers started connecting them to the cloud because a lot of the applications were already moving to the cloud to take advantage of all the new technology options and flexibility that cloud offers. But there weren't many options for running these large HANA systems in cloud. There were also other service providers who would offer similar solutions to connect hosted HANA instances with their cloud environments. We think that this was complex, inflexible, and sometimes led to performance challenges. As we talked to our customers, we got feedback over and over again that the best way to run HANA for our customers was to run natively in cloud in their VPC where they run their application servers. We got this feedback from all of our early customers who were already running on our X1 and X1 instances. And we realized that that was the most simple, flexible, and predictable performance that we could offer to our customers. So with this, we decided to build these instances with this overall vision in mind, where we wanted to offer these instances natively within AWS. And that's where we build this EC2 high memory instances, family of instances with 6, 9, and 12 terabyte memory. I'm going to talk about 4 key aspects of this family. Number 1, they offer 3 sizes, 6 terabyte, 9 terabyte, and 12 terabyte. They're powered by the latest generation Intel Xeon scalable processors, the Skylake family of processors. And they're certified by SAP to run HANA with up to 12 terabyte of memory. Second, these instances are native to AWS. You can run these instances in your existing VPC where you're already running your application servers, or probably you are already running your HANA deployment on R4 or X1 or X1E instances today. Now, this is native to AWS. That means that you can take advantage of all the other AWS services. You can take advantage of the Amazon EBS Elastic Cloud Storage. That means you can only, you can decide to deploy storage that is required for your application at that given point of time. You don't have to over-provision. You can elastically increase your storage capacity as your workloads grow. And you can also connect to other AWS services like S3, IoT, serverless, machine learning, because these instances are part of the VPC, so the connectivity to all the other AWS services are available out of the box. Third, simple management. I really want to focus on this point because it seems like an easy thing to say that we offer access through command line or console. But what I want to emphasize is this is the exact same experience that you already have today with AWS CLI and AWS console with all other EC2 instances that you already use. And these instances are part of the same identity and access management framework as the rest of the AWS. And the fourth point, flexibility to scale. If you are running your large HANA systems on-prem or in colo, that would mean that you would have to plan ahead for your data growth. If you're running a 6 terabyte system, and if you think that you would go to 9 terabyte within 2 years, you likely don't have the flexibility to start with 6 terabyte and then go to 9 as you experience data growth. With EC2 high memory instances, you can start with the instance size that you need today. And when you experience data growth and when you do need to go to a larger instance size, you can quickly do that transition through simple command line interfaces. And when you do that, your storage volumes, your IP addresses, and the other properties of that instance, they move with you. So essentially, you are just doing an instance resizing from 6 terabyte to 9 terabyte to 12 terabyte. Okay, so let's talk a little bit about the technology behind these instances. As we started thinking about the architecture for this instance, we looked at different options. We looked at virtualization. We looked at the ability to offer bare metal performance. And we realized that at this scale, bare metal platforms offer the optimal way of running large HANA deployments. How many of you are familiar with the EC2 bare metal instances that we announced at last reInvent? Great. So we use the same technology to offer these instances as bare metal instances. All of these instances, 6 terabyte, 9 terabyte, and 12 terabyte, they're EC2 bare metal instances available in AWS. That means you get the bare metal performance, but you still get the flexibility and integration of of the AWS cloud. They are supported by AWS CLI, SDK, and AWS Management Console, and you can use them in multiple availability zones and regions, just like your other EC2 instances. Okay, let's talk a little bit about the performance characteristics of these instances. So the API names for these three sizes are U6TB1.metal, and then 9TB1 and 12TB1. All of them offer 448 hyperthreads, and they offer 25 Gbps of network performance and 14 Gbps of dedicated bandwidth to Elastic Block to Amazon EBS Elastic Block Storage. They offer 480,000 SAPs, and they're all built on the same 8-socket platform. So let me actually show you the underlying platform. So these are the first ever EC2 instances to be powered by an 8-socket platform. This platform is powered by 8 Intel Xeon Platinum Skylake series processors with total of 224 cores, which gives you 448 hyperthreads, or what we would call logical processors. These instances are available as EC2 dedicated host. This is another important aspect of this product, where using the dedicated host product, by the way, all the other SAP certified instances that Steve showed earlier, they are already available as dedicated host. These high memory instances available as dedicated hosts would mean that you get the entire host and you don't share the resources with any other customer. Since they are bare metal instances and dedicated hosts, that means you get the infrastructure dedicated to you, but at the same time, you get the integration and flexibility of cloud. Dedicated hosts are already available within Amazon VPC, so these instances take advantage of that integration. And what that offers you is you have the ability to view and maintain visibility into the underlying host for your audit or for your compliance purposes. So what do all of these things mean when you actually look at your overall architecture for running HANA and your broader SAP landscape? So let's take the example of running your current SAP landscape in AWS. Let's say you're already running your application servers, you already have a HANA system running, or maybe you're looking at standing up your HANA system in AWS. You're looking to utilize Elastic Load Balancer, EFS, Amazon S3, IoT, Amazon SageMaker, and all of the other newer services that are being announced at this reInvent for your applications. But at the same time, these applications are tethered to the HANA database. With EC2 high memory instance, you get that dedicated host and the EC2 high memory instance within your VPC, within the same availability zone, along with the Elastic Block Storage volumes, where you're running everything else in your SAP landscape. So now you have this easy out-of-the-box connectivity between your HANA database and your application servers. And we think that this is a very powerful mechanism for you to not only run your production deployments, but also experiment with your test dev environments and a lot of other usage scenarios, some of which one of our customers, Matthew, will share today. One more thing, you continue to take advantage of the business continuity options that you get with the availability zone and region concept. So you can deploy things like HANA System Recovery or HANA System Replication, HSR, and you can set up HA between two availability zones in a region, and you can also do disaster recovery across multiple regions. With this, I would also emphasize the fantastic option of reducing your TCO and increasing flexibility with Amazon EBS. Amazon EBS the EBS volumes are supported with these instances. It's certified by SAP to run HANA. And what it allows you to do is you can provision the capacity that you need today, and then as your business needs grow, without any downtime, you can continue to scale up your storage capacity. You can modify live volumes attached to an instance. You can dynamically increase size. You can tune performance, and you can change instance types. So we offer different instance types. IO1, which is suitable for very high IOPS workloads. Then we have GP2 and other EBS volume types that you can take advantage of. But by having the flexibility to not commit to a specific volume capacity, specific IOPS performance, or a specific type of storage upfront, gives you the option of reducing TCO and increasing your flexibility and agility for your deployments. So with this, Steve, do you want to talk about what all of these things mean in terms of collective benefit for deploying HANA?
Sure, you bet. Just another note. So we've seen customers do some really interesting things, right? And I used to be an SAP guy for over a decade, and I would typically, when I was sizing landscapes or environments, I would think at least 3 years out, most likely 5, on what my needs were from a performance and a size perspective, and then I pad it by another 20, 30%, because I didn't want to be the guy that was wrong, because ordering infrastructure when you're out of capacity is not a fun place to be, right? And so what we've seen customers actually do is start with a virtualized X1 platform, 2 terabytes, move to 4 terabytes when they need it, use the elastic block store volume feature of live extension, right? And be able to extend those volumes as needed to support, the additional storage needs. And then actually move from a virtualized 4 terabyte platform to a 6 terabyte platform in a matter of less than an hour, right? Because it's all built on the same underlying technology. So I'll repeat that, going from a virtualized platform to a bare metal platform using the same images, which is pretty interesting. So one of the things we've been doing for a few years now is trying to remove a lot of the heavy lifting that comes with the automation and the deployment of these types of systems. For those of you that have been in the SAP world for a while, you'll know that traditionally there have been appliance models for things like T-Rex and then HANA. And so really what we've done is we've gone through all the pain and the work of actually tuning, certifying, and making sure that the platform itself is performant, but is also configured in the right way. And we provide what's called a quick start for HANA, which again does all this configuration in an automated way. It uses CloudFormation and orchestrates all the API calls that are needed to spin up the instances, attach the storage volumes, lay out the file systems, install HANA if you want to do this. And we can actually install, regardless of whether it's a virtualized instance or a bare metal instance, we can have HANA up and running in less than 30 minutes, right? So it's pretty amazing. This is open source, so we see customers, we see partners actually taking this and running with it and doing lots of really interesting things. And we're building on this, right? So we recently released a new version of Quick Start that includes the NetWeaver stack. So again, the automation of deploying the NetWeaver application stack across multiple availability zones is something we also support. I talked a little bit about how easy it is to scale up across instance sizes and across instance families as well. So this is just a simple example. Let's say I wanted to actually move from a 6 terabyte instance to a 12 terabyte instance. What would that look like? Really, all I have to do is shut down HANA. Obviously, I'm going to have a maintenance window of some kind. I'm going to shut down HANA. I'm going to go into the console or issue an API call to change the instance type, and then I'm going to start the system back up. It literally is that simple. And then, obviously, restart HANA, resume the SAP application, and then I'm off and running. For now?
Sure, thank you. So to summarize, we believe that EC2 high memory instances offer a simple and flexible way to run your SAP landscape, including your HANA deployments in the cloud. It offers predictable performance, and it lowers your TCO. And the kind of integration that we have done to be able to get to this stage, we want to show you an example of how integrated and how seamlessly connected these instances are. And for that, we have a demo, I guess, Steve.
Well, we're going to see if the demo gods are nice to us today. It's always interesting to try to do a live demo. So now I'm going to be a little facetious here, right? And this is just to show kind of how integrated this offering is, right? So what you see here is actually the AWS console with a 2 terabyte instance, right? So let me show you this here. This is a X132 extra large system. It's a 2 terabyte platform. You can see this has got my HANA demo running on it. If I actually just log into a system that has HANA Studio running, we take a look here. I have a 2 terabyte, just about 2 terabytes available for HANA, right? So again, just to kind of show you how seamless and how easy this is, we're going to do a little bit of show and tell here.
Okay.
Okay. So let's maybe think up a scenario. For now, maybe you're an IT operations guy.
Okay.
You're responsible for running and operating a mission-critical HANA environment,
system?
and you want to go on vacation.
Oh, and I think my HANA system is 2 terabyte.
It's 2 terabytes, yeah.
And now I'm on vacation, and I get a call that we are running out of memory, and we need a bigger box, and suddenly I need a 12 terabyte box. I don't know why, but now I need a 12 terabyte box.
It was pretty rapid.
Yes.
Yeah.
So what do? Well, I'm traveling on my vacation with my Amazon Echo device. So I'm going to see if Alexa can help us try to resize my 2 terabyte HANA box to 12 terabyte HANA box.
I just happen to have one here. Let's see what happens here. So we'll ask Alexa, ask Elastic Compute to scale up HANA to 12 terabytes. We'll give this another go. Alexa, ask Elastic Compute to scale up HANA to 12 terabytes.
HANA instance resized to 12 terabyte has been initiated. We will notify you once it's complete.
Okay, interesting. Let's see what's going on here. Crossing my fingers. Oh, interesting. So we're stopping an instance here. Now, I didn't do that, right? This is all integrated. Alexa's doing all this because she likes to do things like that. So this is a little bit like watching paint dry. I actually used to joke with my girlfriend that I was actually working when this kind of stuff was happening, but you can automate this kind of thing. So why don't we do this? Why don't we ask Matthew to come on up, tell his story, and then we'll check back on this in just a little bit.
Okay, I think there's a problem with the clicker. Let's see if
Yeah, let's give it a go here. There you go.
Okay.
Thank you.
Thank you.
Good afternoon, good evening. I know I'm between everyone and dinner, so I'll try to be brief. I'm the Senior Manager of Infrastructure Engineering and Cloud Operations at Whirlpool, and we were one of those customers that was really pushing Amazon to do better with HANA in public cloud, because we were one of the ones that needed it. First, a little bit about Whirlpool. Most people, I think, know that brand, but we also operate under a number of different brands, many of which you probably know: KitchenAid, Maytag, Genair, and Amana in the United States, as well as a number of other brands internationally. It's a almost 100,000 person company, 70 manufacturing and research centers, and over 100 years of history. So it's a really interesting company to try to take into the cloud because it's gone through a number of evolutions and continues to do so. So we've been cloud first since 2013. And I start here because it'll put into context some of the problems we ran into when we started to try to do HANA, which helped drive some of Amazon's work. I think a lot of these will resonate with the people in the room. Speed and reliability were obviously key components of our strategy. We wanted to move faster, and we wanted to get a very good reliability and performance from the cloud. But we also wanted elasticity and flexibility, and what we meant by that was the idea of this capacity on tap. I don't ever have to worry about running out of memory, running out of storage, and I can deploy new esoteric types of hardware without having to do a lot of upfront development, R&D, and expenditure to get those capabilities in an on-premise data center. We started down this journey in 2013. And because of our goals, we were from the get-go focused on public cloud. In fact, initially we were focused on software as a service. And for the first 3 years of our journey, we exclusively focused on software as a service use cases. And it wasn't until 2015 that we kind of turned around and started looking at the greater data center and said, how can we now be cloud first for everything, not just the things that have a good SaaS play? And that's when we started developing our infrastructure as a service capabilities. But because we were so aggressive with our strategy in 2015, the industry wasn't quite ready for the kinds of monolithic enterprise applications we wanted to bring to the public cloud. We were operating our primary enterprise databases on DB2 on mainframe. It was very hard to go to HANA in cloud when we were looking at 2, 4, and then up to 8 terabytes of memory for our appliance needs. So we had a divergence of our strategy. We started going down both a private and a public cloud path at the same time, and we had to sacrifice some of our goals doing that. I'll get to that in the next slide. But in the meantime, we also focused on deploying in public cloud because we knew that that's where we wanted to be and that the industry would get there. And in 2016, we did a pilot of public cloud with an initial set of applications, some SAP. And then in 2017, we were able to say no more on-premise servers. All server requests went to public cloud. And then in 2018, in earnest, we started really migrating our on-premise workloads en masse. And as you can see where we are in our growth, and we're continuing to work on that. So what was it about 2015 that was a problem? So what you heard earlier about the co-location solution for big HANA use cases was something we ran right into. What we found that the industry had a lot of complex workarounds to make bare metal HANA appliance work well with a public cloud or even a private cloud environment. You had to use NATing or overlay networks to bridge the networks together. The cloud provider needed their hook in to be able to manage the physical appliances, and that created backdoors that security teams just love when you're talking about a data center that you don't own and control. So it created a lot of problems for us. We worked through them, but we had to sacrifice a lot of the goals we set out to have, because again, we're talking about physical appliances, so all the trade-offs. Physical storage, it's very hard to reconfigure them for new use cases. If one breaks, you're waiting quite a long time to get a new server shipped to you. Just buying them up front can take time. So, for a company that had been virtualized for over a decade, it was all of a sudden back to the early 2000s where we're dealing with mostly physical servers. And then, of course, you have the management hassles of now you have a management tool set for your physical server, a management tool set for your virtualized platform, and all the complexity that entails. So we started talking to Amazon and said there's got to be a better way to do it. And that's where this offering came in for us. So I can't express enough how happy we were with where we ended up, because we were able to get back on track with what our goals were, which was to have all the speed and reliability of cloud and all the flexibility of it as well. And by bringing the physical HANA server into the virtual environment, we were able to regain a lot of what we had hoped to get when we started this journey in the first place. And some of the use cases I'm going to mention that we're already leveraging really are enabled by this, especially the storage layer, the integration with the virtual storage layer that wasn't possible on classic physical appliances. And if you're already an Amazon customer, I'll tell you right now, all the management tooling, it works. You really don't know it's not an EC2 server. And we told Steve from the get-go it had to be anticlimactic. You needed to not really care or know that you're not just in another EC2 instance. So the two use cases we looked at, first was a little bit unplanned. Literally 2 weeks after we got access to the beta program, we had an emergency request from our Latin America region. They had a need to deploy a production change for regulatory reasons. And because of the cycles, back to the flexibility issues of reconfiguring physical servers, they were only going to be left with about 24 hours to test the production change before having to deploy it, which for an enterprise is not a great situation to be in. So they came to our global infrastructure team and asked, they were thinking, are there any other environments that aren't being used right now that we can use to buy ourselves some more testing time because we've got projects using the only ones we've got access to right now? They didn't know we just had this capability. They said, yes, but we're going to do it in Amazon. And after they got over that minor aneurysm, we had to figure out how we were going to do it. And we just gotten access to it. So we hadn't deployed it. We hadn't installed anything on it. We just had an empty server. So we looked at, well, what can we do to move quickly, given that we only had a data respond? So we said, we've got this HANA box over here. It's only an R4. It's small, but it's SAP SUSE 3, so should work. So we crossed our fingers, shut it down, took an AMI of it, and booted up to see what happens. And it just worked. And that sounds anticlimactic, but that's exactly what we wanted it to be. We took a server that we'd been running for a year, and we just booted it up on a physical. We took a virtual server and booted it up on a physical server, and it just worked. No hoops, no fancy networking, natting, crazy solutions. It just worked like any other EC2 server. And we were able to deliver the test environment to them 5 days ahead of their other options, which gave them 5 days of testing instead of 24 hours of testing, so they could go into that production change with a lot more confidence. That's great. Well, what can we do next with that capability? So we have these really big HANA appliances with a lot of data, and in the past, it's taken, we live and die by keeping our test data as close to our production data as possible, so that when we test things, we're not running into issues where the data's stale and leading to failed tests, or worse, tests that pass but will fail when we go into production. So we wanted to shorten the QA refresh cycle so we could do it more frequently. The old cycle on the physical appliances took 5 days. We had to take a quality environment down for 5 days so we could take the data from production, reprocess it, clean it, put it back into the quality environment so we could then test it on clean data. We don't keep a lot of these, even in Amazon. These are expensive systems, so we don't keep a lot of extra ones lying around. So we have one per landscape, and asking projects to take 5 days out of the year where they can't do anything, or worse, multiple times of the year, is not a great conversation to have. So we looked at how can we do this offline, and that's where this solution came in. We were able to look at having an AMI for all of our landscapes that we would need to refresh data on, and having basically a shared QA refresh system. Now, you technically could try to do that with a physical server, but it'd be really hard to reconfigure it all the time for your next QA refresh. But with the integration with EBS and AMIs, we pre-build all those, and then we just pick the AMI we need at that moment, boot it up, load the freshest copy of data, we reprocess it offline from the main quality system, move the data back, and then it's just a 5 hour or so at downtime, however long it takes to load the memory, of downtime for the QA environment instead of 5 days. So 5 hours instead of 5 days. We're able to reduce a huge portion of downtime for our projects and get fresher data into the testing cycle so that we're not having issues with our testing. That means faster time to market. That means more reliability getting to market. And that means happier customers, which of course makes me happy. So that's all I have. I think I'll let Steve get back to his demo. Thank you.
Thank you very much.
No problem.
Yeah. Steve, do you want to see what's going on with Alexa?
Let's see what's taken here. I actually want to thank Matthew really quickly for sharing his story. That's not one of the primary use cases I'd even thought about when we first started down this journey.
Exactly right.
It's amazing what, and we're continually amazed by what customers do. So let's take a quick look here. All right, so immediately we're back in the console here. It's a bit small here, but you can actually see the instance type here is changed to U-12TB1.metal, right? It's in the same availability zone, same HANA system. We've just actually booted back up. Well, let's actually just go double check because, well, we just want to do that. So here we're back in HANA Studio again. You see we've got 2 terabytes of RAM. Let's just do a quick refresh. Let's see what happens. Refreshing. Wait for it. Yeah, look at that. We're up to just about 12 terabytes. That's pretty cool. Now, if we hop onto the OS here, I'm actually not going to do that. It looks like that's timed out on me. It's awesome. There's always something, right? But you can see how it looks like the system's still coming up. But thank goodness we were able to show that. But yeah, I mean, that just shows like the integrated nature of how, again, we can go from a virtualized platform to a physical bare metal platform. It's part of EC2. You probably wouldn't resize a HANA system like this with Alexa, but Alexa's integrated with the rest of AWS and EC2 as well, right? So it shows you some of the things you can actually start to do with some of the other services, right?
That's exactly right. So what's next? Now that we have SAP certified instances for running HANA starting from 244 gig of memory up to 12 terabyte of memory, what next? So now as we have customers who are already experiencing the power of AWS platform on 6, 9, and 12 terabyte instances, we're already receiving requests for even larger sizes. And that's where we're planning to launch larger instance sizes with up to 24 terabyte of memory next year in 2019. So this is something that we are very passionate about. We believe that the best way to run the SAP landscape, including your HANA environments, is in the cloud, because then you get to experience the power of these platforms, but also everything else that the AWS cloud has to offer in terms of all the new services and flexibility and agility for your business applications. So this is the story about infrastructure, but we want to go beyond what we do here specifically for HANA deployments.
And this is really borne out in what we see customers actually doing, right? So when you think about kind of what we've accomplished with infrastructure, infrastructure is no really longer a barrier, right? Whether it's large HANA systems or elastic storage volumes, it just works, right? And so what we see customers doing who have now been on the platform for quite some time, about a year and a half or so, they're actually starting to get through the optimization phase. They've actually optimized HA and DR strategies, their whole kind of DevOps concepts, even with SAP systems. And they're starting to actually experiment with some of the new technologies, right? How do I actually enrich my data lake with SAP data? How do I actually start working an IoT strategy again, with my SAP solutions? Some of this is being done natively with the AWS platform. A lot of this is being done through integration with SAP Cloud Platform and our partnership with SAP there, right? So it doesn't stop it, and it's not stopping at infrastructure. It's actually, it's kind of the second wave of adoption we're seeing with SAP customers, and that really is on the digital transformation, the innovation front. So everything is possible today, right? There are no really barriers to actually migrating large systems to AWS, whether that's non-HANA or HANA. Customers are actually transforming their businesses, moving to new SAP solutions like S4, or very large, distributed, complex ECC deployments. They're now actually, again, working together with us and SAP to actually extend these innovations they've done and systems they've had for decades in a lot of cases, to take advantage of some of the new emerging technology like IoT, machine learning, and whatnot, and really be able to apply new concepts like DevOps and whatnot to some of these new types of environments. So really, there is no need to compromise. Where before, either you had to, and you heard Matt talk about this, right? Where you had to make some trade-offs for systems of this size. You might have to use a colo environment to deploy these on-premise. There really is no need to do this anymore, right? Our goal here is to provide self-service solutions to customers so you don't have to compromise your needs.
So that's the end of our presentation. Thank you very much. We really appreciate your time. And thanks, Matthew, one more time for being a great supporter of our work and continuing to provide us feedback on what we continue to do. Thank you. We're going to stay back here for any questions. And please don't forget to take the survey. It really helps us improve our presentations for next year. Thank you very much.
Yeah, we have time. We have time. Actually, we have mics here. If there's anybody who wants to come up and ask a question, we're more than happy to take those.
Yeah, I have a question.
Sure.
My customer systems, they don't grow from 2 to 12 terabyte overnight. So,
Yes.
do you have any plans on creating flexible sizing of EC2 instances? Because my customer systems, they don't grow even from 1 to 2 terabyte overnight, and still it is a big investment to do. It makes me think of the old days when you had to procure hardware for sizing that is not needed in a very short period. So, is there anything planned for that?
Yeah, so I mean, you really have a lot of options. You don't have to go from 2 to 12. Like there's a whole lot of options along the way, all the way from 244 to half a terabyte to 768 to 1 terabytes to 2 up to 4. And we have currently in the works plans for additional refresh of the current environments as well. If there's specific dimensions that you don't see, we'd love to hear what those needs are.
It's about the big steps you have to take once you move to the X1 series, right? So we have a 1 terabyte box. The next step is 2 terabytes. We're looking for options to scale to 1.25 or 1.5, I don't know, without having to create a scale-out cluster, which is quite complex.
So I think that's a great point. And as we have built these instance sizes, we have realized that offering more granularity helps. So as we continue to upgrade our instance families, we are looking at different options of to essentially offer what you're saying, which is how do we offer more granularity? Specifically within the realm of HANA, at some point, more granularity essentially becomes a moot point. So what is that threshold at which that level of granularity really helps? That's what we are trying to understand at this point. So I'd like to touch base with you and get more info. But certainly, this is one of the areas where we do realize that offering more granular memory sizes for HANA does help, not just from the flexibility point of view, but also from the TCO point of view.
Thank you.
Good feedback. Thank you.
Quick question. You had talked about scaling up an instance from a lower size to a bigger size. Is it possible to actually go down?
Absolutely.
Yes. Within EC2, absolutely, you can come down. There are different commercial aspects where we can circle back and offer you different concepts on what commercially makes sense. But yes, you can scale up and you can scale down all the way up to 244 gig of memory.
Yeah, because what I read from reserved instances perspective is you can scale up within that family, but you cannot scale down. So
correct. So
does that apply to this also? Or not?
So specifically within the context of this family, yes. From the reserved instance purchasing model point of view, you can scale up, but you cannot scale down.
Right.
That's true. But that's primarily applicable to the 6, 9, and 12 terabyte of instances. If you have convertible reserved instances for all the other instances, R4, R5, X1, X1E, then you can scale down as well, as far as you have convertible reserved instances for those sizes.
All right, so these two use cases are separate?
Separate,
okay.
Yeah.
Thank you.
Yeah.
This one works too? Cool. Hi, I'm in the process of building out an SAP HANA system, and I haven't quite decided what I'm doing for HA. I'm sort of leaning towards pacemaker. Thoughts on that?
Yeah, so there are a number of options, right? You can use pacemaker cluster. Are you using SUSE or Red Hat?
It'll be Red Hat.
Be Red Hat, okay. Yeah, so starting with RHEL 7.5, you can use the pacemaker cluster. That actually integrates well with some of our native capabilities around, again, taking and using the multi-AZ concept, where you can use an IP address that'll fail over from one AZ to another, using the Route 53 if you want to have DNS switch. So that can be fully integrated as well. Those changes have been picked up by Red Hat and are made available in the Red Hat solution as well. But we can have an architecture session. We'd love to do that with you.
Oh, cool.
Yeah.
Any more questions?
To keep the data in between, sure.
All right, awesome.
Right. Thank you very much. Thanks for coming.